Hello everyone, my name is Yusuf Abu, a student in Bilkent University, Electronics Engineering. Recently finished the course Analog CMOS Design by Professor Atalar. One of the requirements of the course was to design an Opamp which is driving 50 ohm load with a high bandwidth. So what you see in front of you is my design, which consists of 14 transistors, has 3 input pins and 1 output pin. The supply voltage is 5 volts. The requirements of the Opamp was supposed to have the input common mode range of 0.6 volts up to 3 volts. I managed to make the input common mode range of 0.6 volts to 3 volts. We're supposed to make the Opamp to have a PM, the phase margin, higher than 50 degrees. That's for the stability. I made it 61 degrees. And so what you see is the schematic of my design. After that, I made a symbol of it as seen in front of you. This is the pin for the bias, that's the pin for the positive input, and that's the pin for the negative input. Then I went on to make its layout. So that's the layout of the Opamp that I designed. I used the automatic generation and the automatic routing, but then the automatic routing of course was giving some few routing errors, therefore I had to intervene manually. After that, I performed the DC analysis of the layout to find out the errors. So that is the result of the DRC, of the Opamp with only area errors. So I managed to clear all the other errors. After that, I went on to do the VLS. That's the LVS, that's for the layout versus schematic analysis, and that was the result. It shows that the schematic and the layout match. After that, I designed my bias circuit as seen in front of you right here. So the bias circuit was having a resistor R poly H of 8 kilo ohm with VDD, also the supply of 5 volts, and a transistor. Then I performed its DRC analysis. I made its layout. I'll show it right now. Library manager, Opamp bias. So it's opening the layout. There you go. That was the layout of the bias. Then again I performed the DRC and the LVS and it matched. Then I moved on to create the quad Opamp. As can be seen here. So that is my schematic for the quad Opamp. So I put together the 4 Opamps, supplied them with the VDD and bias. Again, I made the layout of the quad Opamp. There it is. That's the layout of the quad Opamp. Do shift F, we can see the interior of it. Then I concatenated all them together with the bias. Then from here I performed the DRC again to make sure there were no any violations apart from the area, which were not the focus in this project. It's running. and I will see our results. So here is the error window. It only shows the area errors. After that, I performed the LVS to make sure the layout and the schematic match. Still running. There you go. So that's the result window. Shows that the DRC violation is 1, which is the area densities, which was not the focus, but again it matches. So we don't need the debugger for this case. And then after that, we went for the post layout analysis. In this case, I will demonstrate 2 post layout analysis. I already have a test bench. So the first one, we'll do the stability analysis. So I put a probe, iProbe, in a feedback loop, and you run in the analysis. You choose to run STB. Luckily enough, I have already run it to save time, and I might as well just run it again. Okay. And so analysis, choose. We'll do the STB. Can start from the 100K point 3 giga. We have to choose a probe instance. We'll select it from the schematic. Okay. Run it. We'll go to result, print. Let's probably not that. On it. Go to result, print stability analysis. So here's our window. It's clearly above 50 degrees, so that means our Opamp is stable. One more that I will do is now to check the bandwidth. With 50 ohm load. Here's the 50 ohm load. So I'll just remove the iProbe. And make a good feedback connection. Feedback connection, check for errors, no error, save it. Let's just simply close all the result windows, not to have any confusion. Nope. Okay, let's close this again and just do it all over. Okay, so lunch, add L. You go to analysis, choose. We'll do the AC analysis from 10 Hertz. We'll do from 1 mega to 400 megahertz. Okay. We'll go to the outputs to be plotted. Select on design.